Good morning, students. It's Miss Haley, lesson 99 on page 409 in your textbook. So if you could turn there. And today we're going to talk about absolute value inequalities. And we're going to graph one-dimensionals. We've graphed the two dimensions. When we graphed the two dimensions, remember it looked like a V, right? And so even when I plugged in a negative value for X, I got a positive value for Y. So that's going to sort of be like what we see today, because if I have the absolute value of X, and let's say it is less than 3, I can even plug in a negative value like -2. So if I plug in, thinking on a number line, -2, -1, 0, 1, 2, 3, -3. Even if I plug in a -2 for X, when I take the absolute value of a negative number, it's always positive. All right? So we're going to have less than, an absolute value is less than a constant, or we may even have a binomial inside our absolute value, less than. And here's what I want you to think when it is less than. When it is less than and you graph it, it should look like a conjunction. What's a conjunction? That's when we've looked at the word and it's graphed like that. So when we solve these absolute inequalities, because if I plug in a negative for my absolute value and it renders me a positive value, I'm going to look, it's going to have two options. First, I'm just going to drop the absolute value sign and solve it as it is. Then I'm going to take the opposite of whatever is in that absolute value sign and solve it. And remember, I don't want to know what the opposite of X is. I want to know what X is. So when I multiply both sides by -1, what happens to the sign? I have to change the direction of the sign. And it's X greater than -3. So my smallest value is -3. My largest value is 3. And when I graph that, and I want you to graph all of these as reals, not as integers. Did you hear that? Graph all of them as reals, not as integers. So because it doesn't equal 3, I have open indicators at 3 and -3, and it's all of the area in the middle. Now, remember interval notation. All right, if I do a bracket, that means it's equal to. A parentheses, that means it's not equal to. All right, so if I were writing this inequality in interval notation, then it would be parentheses -3, comma 3. Or if I were writing it as one inequality, I would put X in the middle. X has got to be greater than -3, but less than 3. All right, so all 3 of these are proper ways to show that. All right, that's a conjunction. Less than, once you've isolated your absolute value, if you have less than something, it's going to be a conjunction. Now let's do absolute value of X. Absolute value of X greater than 3. All right, if less than is a conjunction, then you can imagine greater than, I expect to be a disjunction. All right? And again, we do the same thing here. We solve it by dropping the absolutes and simply solving the inequality. And we take the opposite of what's in the absolute and solve the inequality. All right, so that's just X greater than 3. On the right-hand equation, when I multiply both sides by -1, reminded myself when I multiply by -1, the sign changes, and X is going to be less than negative 3. So what does that look like on a number line? All right, it looks like an OR, right? X is less than negative 3. That goes to the left. X greater than 3 goes to the right. All right? And we're going to talk about 2 exceptions at the very end of this video. But for now, let's work through our practice problems, okay? So hang with me. As you can see, this is my preferred method of videoing. So I probably will continue this route. All right, so I want to work 99.2 on page 410. So we have the opposite of the absolute value of x plus 3 greater than 0. And remember, I always want your domain to be all reals when you graph them, all right? So my first step is I want to isolate my absolute value, the inequality, everything else on the other side. So I subtract 3 on both sides. I have the opposite absolute value of x greater than negative 3. I do not want that negative outside. I want to isolate my absolute value. So I'm going to multiply both sides by negative 1, remembering that flips the sign. So I have the absolute value of x less than 3. What did I tell you about less than? I'm expecting it to be a conjunction. All right, and I always have 2 equations. I drop the absolute value. I take the opposite of what is inside the absolute value bars, and then I solve it. Multiplying by negative 1, this is what I end up with. That's just what I graphed, right? Negative 3 to positive 3, and that's our solution. Okay, what if this were less than or equal? All right, here's a key. When I multiply this equation by negative 1, I do not lose my equal sign. And my indicators at 3 and negative 3 are darkened. Remember, do not please do this on the line. It's kind of hard to see. So try to work these exactly how I'm working them. All right, look at 99.3. Example 99.3. All right, 99.3 on page 410. The opposite of the absolute value of x plus 2 less than negative 2. This one actually is in all reals. So I begin by subtracting 2 on both sides. So I have the opposite of absolute value of x less than negative 4. When I multiply both sides by negative 1, the sign flips. Now I have a greater than. My greater than I'm expecting to be a disjunction, right? Opposite directions. So I drop the sign and solve. I take the opposite of what's inside the absolute and I solve. When I multiply by negative 1 on both sides, the sign flips. I have x less than negative 4. Graphing that, less than negative 4 goes in that direction, greater than 4 goes in this direction. So once you've isolated that absolute, you should be able to tell by the sign, less than is a conjunction, greater than is a disjunction. Okay? Of course, you got to remember what a conjunction is and a disjunction. Conjunction is and, disjunction is or. Okay? Now, there are 2 special cases. And I really want to look at them together. All right, let me get a different marker. Absolute value of x less than a negative number. So once you've isolated your absolute value less than a negative number and the absolute value of x greater than a negative number, okay? Now, think logically. Can I take the absolute value of any number and it be less than a negative number? It's impossible, because no matter what I plug in here, let's say -5, it's always going to render me a positive value. Even if I plug in 0, 0 is not less than -2. So anytime you have absolute value of a number is less than a negative value, your solution set is going to be null. There are going to be no solutions. Okay? No solutions. That's a little light, isn't it? I'll go back to black. Okay? Now, that's less than a negative number, no solutions ever. Okay? Because you will always end up with a positive value once you take the absolute of whatever's inside the bars. Okay? Now, absolute value of anything greater than a negative number. Look at this. No matter what I place in here, let's say -100 greater than -2. -100 is clearly not greater than -2. However, when I take the absolute value of -100 is, I could take the absolute value of 0. I don't know why I said z. 0 is greater than -2. So when you have the absolute value greater than a -2, this is going to be all reals. It does every real value, every real number that you plug in for the absolute value, it will be true. This inequality will be true. Okay? So, when you come to a problem and has absolute value less than a negative number, your brain should say no solutions. Absolute value less than a negative number, all reals. Okay, hope you have a great day.